Hi, welcome to our video on understanding gradients. So first of all, what is a gradient? Well, a gradient is also known as a slope or an incline, and it describes to us the relationship between the change in rate of two variables x and y, as we'll know them on a graph. So this basically tells us how x changes as y changes, and similarly how y will change as we change x. And the definition and the way we calculate a gradient is change in y divided by the change in x of the line, where the triangle represents delta, which basically means changing. The way we work out the change in y or the change in x is by finding the difference between 2 points upon that line. So 2 of the y coordinates and 2 of the x coordinates, and dividing them through. So when encountering gradients, there's 4 possibilities we can have. So the first one will have a positive gradient where this gives us a positive number, and that will be represented by a line in this direction. The second one could be a negative gradient where this gives us a negative value, and that will be a line in the opposite direction. The third could be a horizontal where the gradient, so this value equals 0, which would be a straight horizontal line. And the fourth, which is a vertical, and that's undefined, so it's nothing we need to worry about at the moment. Okay, so we start with an example. It's in the format of many similar GCSE questions on gradients, where we're given a straight line, a graph, and 2 coordinates of the line, indicated by the red dots, and also followed off by the respective x and y coordinates by the dotted red lines. And I've also drawn in a triangle here, just for you guys to visualize what the change in y and change in x actually means. So we have the y1, y2 and y1 difference, which is indicated by the vertical part of the triangle, and the x2, x1, so the change in x, which is indicated by the horizontal part of the triangle. So we're given our 2 coordinates, and we can label them anyway. So we could have this is x1, y1, and this is x2, y2. We'd still get the same answer for our gradient. So at this point, all we literally do are substitute in our x1, y1 values into our equation for a gradient, and similarly our x2, y2 coordinates. And we strongly advise, if you are reading or watching along at home, to pause the video and have a go for yourself. Okay, so we continue with the example. So we hope you guys had a go at home. So all we literally do is plug in our values. So we have y2, which is 4, y1, which is 2. So we have 4 minus 2, divided by x2, which is given by 8. x1, which is given by 4, so divided by 8 over 4, which gives us 2 over 4, which can be cancelled down to a half, which gives us our value of the gradient. So in real terms, what that actually means is for every one value we go across on the x-axis, our y value will increase by a half. Similarly again, for every one we go across on the x, y will increase by half. And another example of this could be if our gradient turned out to be 5, for every one we go across on the x-axis, y would increase by 5, and so on for whatever value of gradient we get. So another important topic you'll come across is the equation of a straight line within GCSE. And gradient is quite fundamental in getting the equation of a straight line. So the general formula of an equation for a straight line is y equals mx plus c, where y and x are the y and x coordinates of any point along the line. M is our gradient and c is our y-intercept. So for this example, we'll have a half equals m, and m is just the mathematical term for gradient, and c is our y-intercept. So all we mean by that is where the line crosses the y-axis. So in this case, it will be here, so 0. Similarly, if the line was higher up and it crossed across 5, it'd be 5, and so on and so on. So this gives us our equation for the straight line being y equals a half x plus 0, which is the same as just y equals a half x. And that's how we can use the gradient to get the equation of a straight line. Okay, so we move on to our second example. Similarly to the last question, we're given 2 points and we're asked to work out the gradient and the equation of the straight line. So if you're watching along at home, please do pause the video and have a go for yourself. Okay, so we continue with our second example. So substituting in our points y2, y1, x2 and x1 from the coordinates. And also guys, remember, it doesn't matter which way you label them. So the top 2 could be x2, y2, and the bottom could be x1, y1. We'd still get the same value for our gradient. we're given 1 minus 2 divided by 4 minus 3, which gives us minus 1 divided by 1, which gives us a value of minus 1 for our gradient, m. So what this means in real terms is this describes to us the relationship of how y changes as we change x. So for every unit we go across the x-axis, the gradient is telling us that y will decrease by 1. So indicated by the blue line, as we go across the x-axis by 1, y will decrease by 1, which fits the pattern of the line. So also, if you remember back to the earlier part of the video where we talked about different types of gradients we'll encounter, we found that this case is a negative gradient, which fits the description of a negative gradient due to the direction of the line. So the direction of the line tells us that as x increases, so as we go along the x-axis, y decreases, and you can see that. So the further along the x-axis we get, the lower the values for the y-axis become. And similarly, any similar line given like this, or any steepness in this direction will also give a negative gradient, where in the previous example we had the opposite, which was given by a positive gradient, where we had a line describing that as x increases, y also increases as well. So using this to equate our straight line, so we need two main pieces of information to get our straight line from the general equation of the straight line, which is given by y equals mx plus c. So m we've obtained through this calculation here, and c we can find from the graph. So c is given by the y-intercept. So in this case, we can see if we follow the line up, the line crosses the y-axis at this point here, which is given by y equals 5. So now we have all the ingredients we need to find the equation of the straight line, where m is minus 1 and c is 5, which gives us our equation for this particular straight line as y equals minus 1 times x plus 5, which can also be simplified to y equals minus x plus 5. Okay, so that's all for today, guys. We hope you enjoyed watching our video on understanding gradients. Thanks again.